the species will stay for it.
Ladies and gentlemen, Assalamu alaikum and a very good morning to all of you, and a very warm welcome to this hybrid event, The Magic of Materials from Basics to Research, organized by Sindh Innovation, Research and Education Network under the auspices of International Center of Chemical and Biological Sciences. We begin with the recitation of the Holy Quran.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الرحمن علم القرآن خلق الإنسان علمه البيان الشمس والقمر بحسبان والنجم والشجر يسجدان والسماء رفعها ووضع الميزان ألا تطغوا في الميزان وأقيموا الوزن بالقسط ولا تخسروا الميزان والأرض وضعها للأنام فيها فاكهة والنخل ذات الأكمام والحب ذو العصف والريحان فبأي آلاء ربكما تكذبان
I now proceed to invite Dr. Nicholas Leventis, our distinguished speaker for today. He will be delivering his lecture on the magic of materials from basics to research. Dr. Leventis earned his BS in chemistry from the University of Athens in 1980 and his PhD from Michigan State University in 1985, followed by a postdoctoral work at MIT in 1992. He completed Harvard's University one-year graduate program in administration and management. After beginning his career in the private sector, he joined Missouri Science and Technology University, advancing to Curator's Distinguished Professor. He also served as a senior faculty member of the U.S. Naval Research Laboratory and as a civil servant at NASA Glenn Research Center, where he pioneered the Allergen Research Program. From 2014 to 2017, he was a professor of material science at the University of Patras, Greece. And from 2019 to 2025, he served as the Director of Research at Aspen Aerogels, Massachusetts. Dr. Leventis has authored over 215 papers, a total of 45 US patents, and his work has received more than 13,400 citations. He has also received honors and awards, including the NASA Exceptional Scientific Achievement Medal and the ACS Arthur K. Doolittle Award. I will now invite Dr. Leventis for his lecture on the magic of materials from basics to research.
Thank you very much for a very nice introduction. Thank you everybody for coming over to suffer
And I
through.
hope this hall will be filled in moments.
Yes, to suffer through another Leventis lecture.
Yeah.
It's like last week, it was. This one is going to be shorter. Okay. And the title is The Magic of Materials from Basic to Research. I will give you like a broad perspective before I start talking. This is, by training, an organic chemist. Like many people I understand this audience. And this presentation basically is very like from organic chemist. I evolved into, I call it the material science, so in Patras in Greece, I was professor of the material science department. So this presentation, in a way, is my take of that transition, what has impressed me through the years, in going from organic chemistry to materials and so on. All right. Remember how this will work, okay? The outline of today's talk is going to be like, we're going to talk about from materials to material science and its scope. We are going to position materials and material science versus materials engineering. We're going to make this distinction. Material science, we will be then focusing on material science as an applications-driven science. Then we're going to go briefly into classification and selection of materials, from metals to polymers to ceramics to composites and advanced. I will be sprinkling all these like properties and processing and about nanomaterials as general as you can get in terms of materials. From my experience, having like Maria mentioned, 45 patents, so I have seen a lot how you maneuver that landscape, get things patented, You might find a couple of pointers of useful, I guess. And then about research on materials. Research on materials is a huge subject, obviously. All right, there is, however, a common denominator in this huge thing, which is materials characterization methods. And that we will, for reasons that I will explain, we will go through an overview of such kind of materials from molecular to nano to bulk. We're going to see several representative characterization methods through the paradigm of 3D nanopore networks, and we will view those as fractal objects. And I want to give you like a, if nothing, sticks out of all these, remember this part, for the fractal objects, that view of looking at an abstraction materials has teeth, is a fingerprint property, and you can arrive to a lot of conclusions, by just finding the fractal dimensions of your structural materials. Okay. Why should we care about materials? Okay, because human civilization is inseparably linked to materials it uses, to the materials it uses. We're talking about the Stone Age, the Bronze Age, the Iron Age, and the question is, what about now? Some people are going to say we're in the Silicon Age. Other people are going to argue. They're going to say we're in the Polymer Age or the age of nanomaterials. Well, another school of thought says that we have to classify in terms of materials our present age from our current understanding of materials. In other words, from the atomic and molecular, from the molecular level. So you might say that we're in the atomic molecular age of materials, and this is the approach coming from chemistry that I like, and we know today our understanding that everything starts from the stars. This is our nearest star. In order to see here, you have to change the total eclipse. That was in North America, August 21st, 2017. I was lucky when I get this picture. And the stars lead to the chemical elements, starting from the stars, you end up with the chemical elements of the periodic table. And chemical elements, as we all know, they consist of atoms. So atom is the smallest unit of the element that retains the chemical identity of the element. That's what the chemist learns. And of course, the physicists, they go deeper, in the atom. They talk about protons, neutrons, and so on, But from chemistry and material science perspective, we don't have to really worry about those things. We worry intellectually, but not in our everyday professional lives. And then we talk about molecules, which are the smallest unit of a substance, where atoms are bound together and act as a single entity. And in this construct, where the materials fall into all this. Okay, materials are collections of atoms and molecules in bulk form. Now, this bulk form can be, some really bulk, some really large, and like a nanoparticle, really, right? Still immaterial, it's a collection of atoms and molecules in bulk form. Bulk form is referred to the scale you are dealing with. Okay, so materials, they can be pure substances, therefore, meaning that they can be pure chemical elements, they can be chemical compounds, or they can be mixtures of the above, like homogeneous mixtures or heterogeneous mixtures. And so, having seen that, what's materials, then what's material science? Well, material science is the study and investigation of the interrelationships between molecular and nanoscale structure and materials and their properties. The material science formed at the intersection of chemistry, physics. I put down mechanical engineering because the previous collaborations I had, over the years, with mechanical engineers, other people that I want to tell you, it's engineering in general. But my good old friends, that they have helped a lot, in my understanding and everything, they have been mechanical engineers. And always the materials is guys, is and it has an application as the point of departure. You don't just study typical materials, just for the sake of the material. That is called chemistry, that's called physics, it's not called material science. Material science starts because you have a need, and you want to find the material in order to fulfill that need. Okay? Having said that, then what's the difference with materials engineering? There are some universities, they have material science department, materials engineering department, like polymer science and polymer engineering, like the University of Akron, for example. Okay, so materials engineering focuses based on structure and property relations in materials, in other words, on material science, on the selection and shaping of materials for the design of structures. For example, they are dealing with parts, if you wish, how you design a part that's going to go to a bridge, it's going to go to buildings, it's going to go to airplane wings, electronic devices, hip implants, like for example, let's take a little more closer look to that. Hip implant, as we know, with age of or certain illnesses, joints that deteriorate, particularly those with large loads, such as, for example, the hips. So this is a healthy hip, and you see, that the bone has been kind of consumed because of friction, here and here, friction disease and so on. So that is a pretty painful situation, and it's a kind of crippling. So as we know, we have hip replacement in order to make the life of these people easier. The hip replacement basically takes this whole disease part over here and replaces it with an artificial collection